Hi sir, this is Vamsi Krishna. Mm, The final project was implementing CNN model using it for the 10 data sets. The agenda was introduction and types of deep learning, CNN architecture, and SIR for 10 data sets, workflow, result, and conclusion. Introduction. Deep learning is a type of machine learning that uses artificial neural networks to automatically learn and recognize patterns in data. It's like teaching a computer how to recognize things by showing it lot of examples. It involves building and training complex neural networks that can identify patterns in data, make predictions, and perform tasks such as image recognition, and natural language processing and speech recognition. And types of deep learning, there are three types of deep learnings, and convolution neural networks and recurrent neural networks and artificial neural networks. A convolution neural networks is a type of computer program that can look a picture and understand what's in them. It works by breaking down the picture into smaller parts and analyzing each part separately. Recurrent neural networks is a type of computer program that is really good at understanding sequences of things. It works by keeping track of what is it has seen before, so it can use the information to understand what comes next. An artificial neural networks is a type of computer program that is inspired by the structure and function of human brain. Artificial neural networks are commonly used for tasks like pattern recognition, classification, and prediction. And this is the CNN architecture. Uh, Convolution neural networks is a type of deep neural network that has primarily used for image clarification and object recognition tasks. They are composed of layer of neurons that are arranged in a specific way to detect pattern in the input data. In this article, in this architecture, uh, convolutional layer, the first layer of CNN is usually a convolutional layer. Convolutional is a mathematical operation that is performed on an input image and a small matrix of weight called a filter or kernel. The filter sites over the input image and performs element-wise multiplication and addition operations to produce a future map. The future map represents the presence of a certain future in the input image. The size of the filter and the number of filters used in the convolutional layer are hyperparameters that are usually determined through experimentation. Large filters can detect large features, but they also increase the number of parameters in the model, which can lead to overfitting. Similarly, increasing the number of filters increases the of the model and can lead to overfitting. And the another one is pooling layer. After the convolution layer, a pooling layer is usually added. The purpose of the pooling layer is to reduce these dimensions of the input, which retaining the important information. Pooling is usually done using max or average pooling. Max pooling selects the maximum value for the regular region of the input, while the average pooling computes the average of the value in the same in the same region in the same region. Um, Pooling layer helps to reduce the amount of computation required in the network and the prevent overfitting by reducing the special dimensions of the sorry partial dimensions of the future maps. However, using too much pooling can lead to lose an important information and reduce the perf- performance of the network. And the next one, activation function. Each neuron is in CNN has an activation function that introduce non-linearly into the network. The most commonly used activation function in CNN is rectified linear unit, which sets all negative values to zero and retains all positive values. The functions helps to speed up the training process and prevents the vanishing gradient problem. Other a- other activation functions that can be used in CNN includes the hyperbolic tangent functions. However, these functions are less commonly used in CNNs because they tense and saturates when the input is large, and which can make training slow and difficult. Fully connected layer, and the next one is fully connected layer. After the CNN and pooling layer, um, a CNN usually has one or more fully connected layer. These layers are similar to those in a traditional neural networks and are used to classify the input image into one of several categories. The fully connected layer takes the output of the previous layers and flatten into a one dimension vector. These vectors is the fed into a fully connected layer which consists of neurons that are connected to all the neurons in the previous layer. The output of the fully connected layer is passed through a softmax function of obtained in the probabilities for each class. And the next one is dropout. One technique that is commonly used in preventing overfitting in CNN is dropout. Dropout randomly drops out some of neu- neurons in the network during training, which focus the network to learn representation of the data. The technique helps to prevent overfitting and improve the performance of the network. And the next one is data argument. Data augmentation is another technique that is commonly used in CNN to improve the generalization performance of the network. Data data involves generating new training data by applying various transformations to the original training data. Some common transformation includes rotating, flipping, and scaling the images. Data automation helps to prevent overfitting by exposing the network to a large variety of input image. The technique also helps to improve the network by making it less sensitive to small variations into the inputs image. Um, and the next one is transfer learning. Transfer learning is a technique that involves using a pre-trained CNN and the CIFAR trend datasets consist of 50,000 images from 10 classes, and each image begins of the size of 32 by 32 pixel, and these are the pictures and the workflow. Um, Importing librarian and downloading and loading the CIFAR 10 datasets, defining a convolutional neural networks model. Define accuracy score, the model, test the model by by loading the test images and making the prediction on it. And importing libraries. Touch provides useful modules to train and implement neural networks models, so we can don't have to start from scratch. And uh, Trojan provides functionality to import image data and perform transformation on it, and train the model. Train the model. The process of training has two parts to it. uh, Training and evaluation. That results a training loss is calculated by comparing those predictions and actual labels granted or reset to zero. And testing the model. Testing the model, we can see our model in action by visualizing some images from the test data and checking if our model predicts them correctly. All through the model performance well on on roughly 79% of images in the dataset. They still lost of room for improvement with data augmentation and recognition techniques. um, CNN is a type, and in the order of the train, CNN model, a large data sets of images is required. The CNN model is trained on these images using back programming, propagation, which adjusts the weight of the convolution and fully connected layer to minimize the error between the predicted output and the actual output. Once the CNN model is trained, it can be used to make predictions on a new image. The image is passed through the CNN layer, and the output of the final full connected layer is predicted class or value. In some and It uses convolutional layer to detect patterns and future in the image, and a fully connected layer for classification or recognition. And these are the results. And The final testing accuracy is 79% after 10 approaches. Thank you.